force. You ready? Brute force. Okay, put these in your brain. Ready, go. Okay. All right, I think a lot of you already know these, which is good. Derivative of natural log is 1 over x. This thing is just saying it's, don't forget chain. Okay. This one, the b to the x, we already went over this one, but. So, guys, quiet please. Shh. 2 to the x. So if you take the derivative, it would be 2 to the x natural log 2. That's the formula for it. So you basically rewrite it and then natural log 2. I'll show you, we'll show you the process to get that. There is a long way to do it, but it's long and annoying. So I would usually just memorize it, but you can figure it out if you need to by deriving it implicitly. The log formula, again, that's like a last one on multiple choice. So maybe they'll do that this year. I don't get the multiple choice. They don't release as many as the FRQs. But so I've only seen like maybe half as many as your FRQ questions, but like they always do that last question being random derivatives or like weirder ones. So again, if you want a 5, studying these weird ones are like the key. So I'll just put this in as like a normal log. Maybe I'll do 2 to keep it consistent. So if you had to do the derivative of it, I mean, you're just following the formula. So like x, or, okay, say you're taking the log of something fancy. Like say it was like x squared plus 3x or something. You'd still put that there. So like wherever there's an x, you're going to put whatever is in with the log. And then you're going to write natural log of the base 2. So it'd be 1 over x natural log 2. Okay, so make sure you have those in your brain. And then e, the derivative of e is e, like the Spider-Man pose. The meme, you know? You guys know, right? Okay, well, we're just going to move on. Okay, so I just did all these randos. Okay, so this first one... Shoot, how am I going to do this? I can't zoom in. Okay, that's going to get annoying. How do I zoom in here? It won't even do it on my mouse. Oh, okay. Well, we're just going to have to write small. Okay, so... Okay, that's not going to erase. Number 1, if I need to find the derivative, maybe I'll mix up the... Oh, no. No, it's not going to write. I don't want to do the... Oh, shoot. Come on, you guys. Why isn't this working? Here, I'm going to close it and reopen it. Okay. Hey. Hey, there it works. Okay. So, to find the derivative, we're going to do a little product rule action, right? So, the derivative of the first times the second plus the derivative of the second. So, the derivative of e is just e times the first. Okay. Now, as far as attacking that minus sign, I would just do a big parenthesis and then deal with it later. So you don't mess that up. Because now we have another product rule. Do you see it? It's a little sneaky. Derivative of the first times the second. Plus the derivative of the second. So notice that it's e not just to x. It's e to like random, like fancy stuff. So that just means you have to do a chain rule on it, right? So the derivative of e to the negative x over 4 would be e to the negative x over 4, okay? But then you have to multiply by negative 1/4. You have to do some chain on it. Open up this parenthesis a little bit. But then also don't forget to deal with your x in there. So whenever your exponent is like a little on the fancy side, don't forget the chain on it, okay? So then now you're just gonna maybe clean this up a little. I mean, not too much, honestly. You could factor out some things to clean this part of it up, but not really. I would just write it. So this would be minus e the negative x over 4, and then remember to distribute the negative. So we have the negative 1/4 and then the negative outside, so make sure you write plus 1/4 x e to the negative x over 4, and then that could be it. So don't forget the chain, essentially, is what I did on that one. And then the way you do natural logs, oh no. What if I did? Nope. Hand. Hey, there it is. Okay. Oh no. Okay, maybe we're good. Okay, we're good. Okay, so when there's like a number in front, you're going to be doing the way you attack the natural log. Instead of it being 1 over whatever's in there, just put 5 over the x squared plus 3. And then because it's not just x, got to be fancy. So make sure you write the derivative of the inside. And then cleaning it up so it's cute is 10x over x squared plus 3 be the answer. Okay. All right. This guy, so for the log one, so this one's probably like old school, you don't remember as much. So to find, maybe I'll mix up the notation. We'll do Lebanese right now. Okay, so for the derivative of log, you have to like put this in your brain. You're going to take 1 over, and then it's whatever is in, you're taking the log of. So like technically, like if it's just log base 5 of x, you would just put an x there, but because it's a root x, you have to follow through. So this has to be root x, and then it'd be natural log 5, the base of it. So like this is like the shell of what log is supposed to be, but because there's a root x, you have to plug that in, and then you're going to have to do the chain on it. So then you multiply by 1/2 x to the negative half, and then you would clean that up. I'll show you a faster way to do this one as well, but we'll get there. So if I do clean this up, I get 1 over, and then I'll have the 2 from the half, and then I have a root x and another root x on the denominator, and then a natural log 5. Okay, so I put the chain rule kind of towards the front, and then you can kind of see where it gets the 2x natural log 5. And that'll be the answer. Does anyone know how to do it faster? There's a faster way to do this. It involves messing with the original. Do you know? Yeah. Yeah. Log base 5, write this as to the half, and then bring it down. Use a log rule. Then you don't have to deal with chain at all. Okay, so you basically get 1/2 times 1 over x natural log 5, and there it is. So that's a little faster. Yeah, you should. But if like it wasn't root x, say it was like something weirder, you'd have to do it the other way. So kind of depends. Okay, now this guy. So this is like that 2 to the x one that I did. Where is it? Right here. So again, same idea. Like if this is just plain x, you're going to put an x there. But if that's fancy, you got to put the fancy stuff there. Okay, and do chain on it. So for this one, to find the deriv. Okay, so you're going to do the 9 to the power thing. So basically it's 9 to the power. Okay, natural log of the base 9. Okay, and then I guess maybe I'll put this in. This is like you got to do the chain on it. Okay, so that'd be times 3. So maybe that one's kind of a weird one, because if it was just like 9 to the x, okay, it would be 9 to the x natural log 9, okay? But since it's like fancy, I got to put the 3x plus 1 in there, and then I got to do times 3. Now, if this was multiple choice, that's probably not going to be an answer, okay? So I want you to keep in mind that you can mess with this a lot. Like 9, do you know you can rewrite that as what? Yeah, 3 squared. So keep in mind that they can be mean. You guys know. Same with natural log. Do you know what I mean? And they can like really mess with you. Okay. So if they're feeling extra evil, just keep in mind that you can like, this would be what, 6x plus 2, but then you still got another 3 going on. And then you can rewrite this as 2 natural log 3. And I can still keep going. So I can bring down the 2 on the natural log, and then I can put those 3's together. Do you know how to do it? What would be the new exponent? Do you know? What would be the new exponent if I put the 3's together? Yep. Because you have to add another 3 to it. Oops, why did I write 5? That was weird. Go away. So if they're feeling extra mean, that's an option. Or they might put this as a 6. That could be a thing. You just kind of have to like work with it, you know? Is there any questions on that? Do you remember all that? I tried to cover like everything in like 4 problems with that. So the rest are like weird ones. These other ones are weird. Oh, this one's painful. Ready? Isn't that? Look at that thing. Ew, right? Do you want to do, what would that be? A product with a chain rule within a quotient rule? Like, no thanks. I wouldn't do that. What you should do is, the strategy for this is to take the log of both sides, the natural log of both sides, and do all your rules. So this is, do you remember it? There's a lot of space. That's how you know it's going to be a good one, right? Because you're going to do natural log of y, and then natural log of this beast. I'm going to write it as x squared plus 1 to the half. Okay. All over this thing. And then you kind of just carry down natural log y until you're ready for a derivative. So you don't do a derivative until like a while. So most of the work is not doing derivatives, okay? So like what you should do is you get your natural log y, and then you should break up your, I don't know why my cursor's following me. It's kind of creeping me out, but that's okay. Do you know what I mean? Remember the log rules. So break up the division with subtraction. So this is what I did. Oops, I'll do a different color. How about? So I broke it up with division. And then whoops, I forgot. What happened to my parenthesis? Okay, then I'm going to break up the multiplication and do the power rule. Do you know what I'm talking about? Do you remember doing this last year? It was like a scary problem. So you get, so this would be natural log x plus natural log of x squared plus 1. And I'm showing a lot of work because it's your notes. But if you want to do, if you've got the brain to do all that in less steps, go for it. Just don't mess up. Okay. So then, oh, dang it, I didn't do the half yet. Okay, so basically you break it all the way down until your powers are down. So I still need another line. And that's when you do your derivative. So you get natural log y equals natural log x plus 1/2 natural log x squared plus 1 minus 2/3 natural log x plus 3. Is everyone still alive? Do you remember this? Because you can only do these because you're solving it implicitly. So what you're going to do then is you're going to take the derivative of the natural log y. So I always bring it down as I go so I don't forget that the natural log is on it. Okay, so what I'm going to do for this this left side, I'm going to take the derivative, so I get 1 over y, but don't forget that you've got to do chain on it because it's a y. You're taking a derivative with respect to x, not with respect to y. So you get 1 over y times y prime, and then you're going to go crazy on derivatives of natural log. So the first one's hopefully not that bad. It's just 1 over x. But then don't forget that chain rule is a thing. So like that second guy, you're going to have 1/2 times 1 over x squared plus 1. But then don't forget that you have to chain it. So don't forget that 2x'er on there. That's usually what people mess up, is they forget the chain on it. And then same with this one, we get 2/3 times 1 over x plus 3. That one doesn't have a chain. So, well, it does, but it's 1, so whatever. Okay. Then, I'm going to clean up the left side. So I'm going to rewrite this as y prime over y. And then I'm left with 1 over x plus x over x squared plus 1 minus 2. I would just, you could distribute the 3 or leave it out. So then, keep in mind, I still got this guy over there. So what I'm going to do is I'm going to multiply both sides by y to get that out. So I'm grand finale, I get y prime, and then my y value is like throwback to original. So my y value, I have to rewrite that psycho thing we started with times all this like fraction difference and sum. So before I like write it, so well, maybe I'll write it out and then we'll get this again. I even forgot. I should just look at my notes so I don't have to keep scrolling. So what was it? X square root x squared plus 1 all over x plus 3 to the 2/3. And this is all times this thing. Brute force. You know what I mean? And you know it's a good question because then when you circle it, it's like a huge oval instead of a circle. You know what I mean? So here we go. The plan is psychoderivative, natural log it. Then do rules for however many times it takes you to get exponents out, to get multiplication out, like getting this multiplication away, to get the division away. So like once you get here, then you're doing derivatives. Don't forget chain. And then don't forget implicit because people forget to multiply the y over. So I put the y in front because that bothers me. You could have it at the end. Is everyone okay where all this stuff is coming from? Yeah.
The last term is supposed to be times 3, not times x.
Yes, thank you for catching that. Why did I write X? Isn't that kind of weird? I don't know. Thank you. Good. You don't need to write this down, but just because it's going to bother me. Like if you did, say you forgot the derivative, right? If you did the derivative, you would take it implicitly. So the derivative, oh, wait, where'd it go? Here. What you would do is you take the natural log of both sides. Okay. Okay, so you get natural log y equals x. Geez, I'm struggling today. No, it would be x natural log 2, right? And then if you took the derivative, it would be 1 over y times y prime equals natural log 2, because natural log 2 is just a number. And then you multiply y over. So there you go. I did your little proof, because it would be y times natural log 2, which is 2 to the x. So if you forgot the derivative of that, you could figure it out, but it's long and annoying. Yeah? Okay. There we go. Next one. Oh, this was F or Q. When was this one? I can't remember. I don't remember the year. Oh, well, that's okay. All right, so we've got let Q be the function by all that junk, okay? Let G be the function defined by all that. Ooh. Let H be a function whose graph consisting of 4 line segments is shown in the figure. Okay, where's the rest of this question? Oh, it's up here. Okay, find Q prime of 0. I was like, where is this? Okay, so where is Q? Okay, this thing. All right, so we got to find the derivative of that. So Q prime of X. Ooh, look at that chain. Isn't that a lot? Hey, that's a lot of chain. All right, so let's see. I've got, shoot, how do I want to do this? I plugged it in later, it looks like. I don't know if that's easiest. I think I'm going to show, because the G is a little psycho, I might do, or Q, no, I'm going to do it. Okay, so I'm going to go Q prime of X, so that's going to be, okay, we've got the chain on H, so that'd be H prime of this, G of 3x, and then I got to work in, so then I got to do derivative of G, so G prime of 3x, and then I got to do a chain on the 3x, so that'd be times 3. Oofda, hey? All right, so I'm going to I need to figure out of 0. So Q prime of 0 would be H prime of G of 0, because 3 times 0, right? And then times G prime of 0, and then times 3. Okay, so now I've gotten it like situated a little bit, but now I need G of 0 and I need G prime of 0. Okay, here we go. So I'm going to do, let's figure out, I guess I'll keep this in red. Let's do G of 0, because where's G? Oh, this thing? Ew, look at that. Do you guys have this internal monologue also, or is that just me? When you do these? I'm just like, where is this? Okay, G of 0, here we go. So what do I get? 0 plus 2? Okay, I can do that. Raised to the sign of 0? What is that? 1? Okay, I'm going to do that. H prime of 1. Sorry, replaced it. Here, maybe I'll highlight this. So this one I got over here. Okay. All right, now I need G prime of 0. All right, where's this guy? G prime, G. Okay, here's G. Oh, no. This is sad, you guys. Don't you think? Because it's got that stupid sign. Ah! That's what you should say. Because I got to take the derivative of that. How the heck am I going to do that? Okay, I need the exponents all fancy like. There's variables and junk in there. It's not a number. So that's my natural log business. That's this thing. This thing. I got to do natural log of both sides. Okay. So for something like that, when your exponent isn't like a number, that's how you know you're going to be doing the natural log stuff. Okay. So you're going to do the natural log of G equals natural log of this thing. So anytime your exponent is fancy, so if it's a variable or like trig stuff or, polynomial, whatever, you need it down. So that's why you take a natural log, because then you can use your power rules. All right. This is going to be a fun one. This is only part of the problem too. Isn't that great? And then we're going to have to do product. So see if you can get it. Actually, yeah. Just do the first step, the first derivative of that. And check with your people that you got it right. This time we have one. We'll be okay. Then we get... So just the first step. This was a mean FRQ, hey? And this was on AB too. Because you get 4 of the AB questions. 2 BC. Okay, so you had to do product rule. Did you get your chain on it? On your second chunk? And then you had to do implicit. So then now I multiply both sides by G. Okay. What was I even doing, right? Oh, yeah, G prime of 0. Oh, my God. G prime of 0. Okay, now I need 0 in this. Okay, so I need to plug 0 in for G. Remember? This is like, so G of 0, I already did. That was 1, remember? So wouldn't that be nice if it was a 0? Gosh dang it, That would have been so much nicer. Okay, so then I'm going to plug in cosine of 0 is what? 1, and then we get natural log, and then 0, natural log 2, plus 0. Yes, at least we can clean up part of it. Okay, so then what does this equal? Natural log 2? Is that what I got last time? Yep. Oh my gosh. Aren't you? It's just that little piece. Oh my gosh. Do you want to cry? We're still not even done. Okay. When does it end? Okay, F prime, H prime of 1. Oh, okay. Is it, wait, what? Wait, this is H prime. So wait, what is it? 1/2. Okay, good. Yeah, you guys know things. Good. Okay, so H prime of 1 is the slope of the line at 1. So that'd be 1/2 natural log 2 times 3. That's like an angry circle, don't you think? Rough. That was rough.